All right.
Cool. Thanks, Sarah. And it's really nice to meet all of you. So yeah, I think the plan that Jess and I have kind of worked out is I'll present a little bit about what is facial recognition and sort of help develop a mental model for it. And then Jess will kind of present what the AG is proposing and what they're asking for. And we can kind of then talk about ways we might want to respond or ways we might want to take this work forward in the future. Since it's so few of us, feel free to interrupt with questions. Like it's totally fine. I think a big goal I have for today is that I personally don't think I find that a lot of technical discussions around police technology sort of lean on the like, oh, this is hopelessly complicated and I don't understand what it's about, so I'm going to keep my mouth shut. And I think a big part of like what I want to do and what I want to help people do is like try to gain an intuition for it so that you can take all the expertise you already have in policing and what the police do and apply those intuitions to just this new technology. So with that, I'll sort of present what we're doing here. And so first, just a little bit about me. I actually have a background as a computer scientist. It's what brought me to work on police technologies and other kinds of technologies that are used to that have harmful impacts on communities. And so I'm really excited that we get to talk about this. For some context, again, the reason we're here is the Attorney General has announced that they're going to be making a policy to regulate the police's use of facial recognition. And they've asked for public comments, and we really want to be able to see as many people comment as possible. We want people to push back where they can. And so hopefully this presentation will help people kind of figure out where they stand and how they might want to approach this and maybe give people an opportunity to respond. So anyway, that's what I'm going to do here before Jess kind of presents on the portal itself for comments. Really, the goal is I want to kind of help develop a mental model for how this works. Some big takeaways that we're going to talk about today about facial recognition is that it's less accurate and produces more mistakes when trying to identify Black and brown faces as opposed to white faces. We're going to try to talk about how that actually works. And so we actually can understand why that happens and why it doesn't have to be the case, but also what harms result even if it were the case that this tool were equally accurate for Black faces as white faces. And that sort of gets into where a lot of your expertise lie. You all know what happens when police come in with like a new tool and, you know, start policing a community. Those sorts of intuitions you have and experiences you have are just as valid for facial recognition. So maybe hopefully this presentation will help give you a language for how to talk about that around a new technology. And another thing we'll be talking about is that this, you know, even in any event, as Sarah kind of said, this tool is like, can be dystopian. Really, we're talking about a technology that when paired with ever-present surveillance cameras, body-worn cameras, and any source of images, really can put people under the microscope every day and constantly broadcast where they are to the police, to the state. And so we want to be able to push back on that. Anyway, please again, interrupt it with questions. If you have questions, we can stop, we can slow down, we can speed up, whatever people need. But anyway, I guess let's get started. So while we're here, I can also share these slides afterwards, so hopefully those will help too. And I hope I'll try to also not rely too heavily on the slides if anyone is not like doesn't have a view of if they're on their phones or anything. Anyway, so to get started, facial recognition can refer to a lot of different things. The context you're probably most familiar with facial recognition on a day-to-day basis is if you have a smartphone or an iPhone in particular that has Face ID. What that's doing is facial recognition. It's looking at your face, finding a face, matching it to a face it's got in its database on the phone and saying, oh, this is Dylan's phone, I know Dylan's face, and this is where, and Dylan is the person looking at the phone now, so I'm going to unlock. There's also other kinds of facial recognition, like gender detection or emotion detection. These come with a lot of issues, and a lot of the things we're going to be talking about today are equally applicable to those contexts. But when we're talking about law enforcement facial recognition in particular, we're usually talking about an application specifically known as sort of face recognition, like face matching or facial identification, as opposed to facial verification. So iPhone's facial verification, we're talking about face matching. Given unknown faces like these people here, we don't know who they are, can we match them to a database we already have of known faces? And so that's really it has an obvious, I think, law enforcement application. The police have a picture, they want to learn who's in the picture easily with no work. And they also have a big database of images to rely on. So they want to match that. But before proceeding with that, it's not a perfect metaphor, but I think the thing to sort of always fall back on when you're talking about facial identification, facial recognition is, in a lot of ways, we're talking about fingerprinting. If you kind of understand the basic concept of fingerprinting, you're halfway there with facial recognition. You take an unknown fingerprint, the police have a Rolodex and a database of fingerprints they've taken, often from people they've already arrested, and they check the fingerprints and they find a match. So it's basically that context, but instead we're talking about face prints. So your face, like a finger, has a face print. It just has to be discovered. When the facial recognition tool takes a face print, it can match it against a database of known face prints from people and produce a match and say, oh, you know, is this person's picture President Obama or President Biden? So that's really like the very sort of simple, that's the simplest model I can give you. And we'll get into specifics onto how that actually works in practice and how it works implicates issues like racial bias issues, discrimination. So for example, now, once we already have this context here where you know about fingerprints and face prints, imagine the question, well, in the fingerprint context, we have databases of people's fingerprints. The police take those. In the face print context, where do those images come from? That raises one of the first issues we have with facial recognition systems, is you need a database of images to compare the face print to. So for example, let's say that picture from before was a surveillance video image, and the police said, I want to identify the man and all the people potentially in this image. They can run it through the system, compare the face prints from that scene to face prints from, say, a mugshot database or the DMV database, and produce a match. So already we can see where there are issues with that. If people in police databases already come from over-policed communities, we know that people of color are arrested at higher rates than white people for the same crimes. Those databases are going to put undue scrutiny on Black and brown faces as opposed to white faces. So that's a major question then, is where do we get those databases from? Perhaps mugshot databases shouldn't be used, but that also raises the issue of what else should be used. Perhaps DMV databases are bad because that subjects almost literally anyone in the state with an ID to facial recognition. Georgetown has a center that does a lot of research on this, and we can share links to you. But one of the phrases they put it, and I think a phrase that people should take away from this talk, is they call it a perpetual lineup. It's like putting everyone in a perpetual lineup at every moment. Another example to consider with this database question and where the images come from is the example of Clearview AI. If you might remember, a couple years ago, there was a big expose on this new facial recognition vendor that was selling to individual police departments and individual users the ability to find anyone's faces. Unlike having to rely on mugshots and the DMV, though, they scraped images. That is, they took images and downloaded images from all over the internet, from all over social media, including tens to hundreds of millions of people. So in that case, there wasn't even a question of who was in it. Everyone was in it. And Clearview AI gave people the ability to do that. The New Jersey Attorney General, fortunately, a couple years ago, banned the use of Clearview AI in the state, at least in theory. Whether it worked in practice, I don't know. Maybe someone else could speak to that. But there's already precedent for this issue of maybe we have to be careful about where these images actually come from. So anyway, that's one of the first issues, this database question. And already you can kind of get that from just understanding how fingerprint works. But in terms of the process of how facial recognition actually works, there are 3 steps we should really talk about. Also, please interrupt with questions at any moment. I know I'm just kind of talking through and I can slow down or speed up anything. But right now you get to see beautiful pictures of myself. I didn't feel comfortable putting a stranger's face in the demonstration of facial recognition, so I'm using my own face here. And so it's a really simple, though, 3-step process, because, you know, with fingerprinting, it's easy to understand, like, oh, you take the ink or a computer and it looks at the whorls and swirls on your computer, but how you actually get a face print is a little more complicated. So take this picture, for example, of me. The first step is face detection. Is there even a face in the picture? Where are the faces in the picture? This step is relatively simple. Usually the system, the software, will just look in the image for something that looks like a face. And literally engineers build tools that are like, what is the best way we can figure out where 2 eyes, the nose, and the mouth are? Pretty simple, pretty rudimentary. But then what it'll do is it'll take that face, skew it into a box, and make sure it's centered for the next step. So already we have the face from the image. The next step is the actual face analysis or feature extraction. That's feature extraction is like the term of art, but I think it's like a useful one for understanding it, because literally it's breaking down your face into its component features that the computer thinks are important. So it can be things like distance between eyes, length of nose, width of mouth, oval, circleness of head, and those things it will put together into a single print, what is essentially the face print. And so those are the equivalent of the whorls and swirls of a fingerprint, really. An important thing to know about this step, though, that is going to be really crucial for a second issue we're going to talk about, where racial bias comes in. So back in the day, when people were first developing these tools, the human engineer would sit down and write out code that said, I think the width of the eyes are important. I think that the size of this person's eyes, or the size of their mouth is important. And they would take out those features and make a face print manually. But now what's done, and this is where the phrases like artificial intelligence or machine learning come into play. What we can do as engineers is teach a program to recognize what are the most important features of the face to take out of the face. Basically, the program teaches itself what the most unique face print it can make is that will make it the best at identifying faces. So hold that thought, but it's an important point that when making a face print, computers teach themselves how to do it based on examples given to them by the human engineer. So they teach themselves. The next slide is the last step, the actual matching stage. Given that database, maybe mugshots, maybe DMV, maybe everyone in the world via social media, you actually want to match the face prints. You'll have taken face prints from those example candidate images. So for example, you actually have my driver's license photo now, congratulations. There I am. You can match the face to the known faces, and then a list of candidates is generated. So for example, in this, the algorithm, the thing that actually matches my face print or the face print from the images to the known database, produces a percent match, like how similar they were. And so here you can see that like D. Reisman, that's me, gave an 85% match, but it'll also list other candidates too that it thinks match, like maybe someone else matched 30%, someone else matched 22%. It's also possible I wasn't in the database. If I hadn't been in the database, it wouldn't necessarily say no match. It would still give a list of candidates. It would just be missing me. It would be missing that first top row there. The first one would be a 30% match, and that would be it. Then it's up to humans to actually decide what to do with that information, which is something that we can talk more at length about later. But anyway, that's really the 3 simple stages of this: detection, extract the features from the face, compare them to a known database. Where inherent bias and racial bias comes into play, though, is that, and this goes back to what I was saying just a moment ago, back to that feature extraction stage. Because the algorithms train themselves based on examples given to them by engineers, they're only as good ever as the examples they are given. maybe it won't surprise you, but there are a lot of bias and disparity issues in the engineering world. People are constantly training facial recognition models on data sets that are not representative of people. And they're not only trained on that, but when they measure the facial recognition tool's performance, they will test it against a data set that's likewise not representative. Most of these data sets, historically, though there have been a lot of efforts to improve, a lot of these data sets historically were white men. My favorite example anecdote, you see those four faces, there's George W. Bush, Gerhard Schroeder, Donald Rumsfeld, and Tony Blair. One of the most popular data sets for actually testing these tools and measuring how they did was on news pictures from 2002 to 2004. So anyone who was big in the news in 2002 to 2004 was in it, which is, guess what, in America, a lot of white politicians. And that's how they tested it for a long time. So you would think, oh, my facial recognition tool did a good job, but really when put into practice, it doesn't, because it never learned how to do faces that didn't look like white men. So even to this day, a lot of tools, and this actually goes back to also, I gave you the example of there are also tools that do gender recognition, like is this person male or female, which has a lot of issues related to whether we should even detect people on a binary, or emotion detection, whether this person's happy or sad. A major study in this was led by this great scientist who's like a big star in the AI field named Joy Buolamwini, who did this big study called Gender Shades, looking at gender detection tools, and basically found how so many data sets used for training are mostly white faces, and that the resulting tools are really, really bad at detecting Black people's faces and darker skinned Black people's faces in particular, and particularly women's faces. And so this is an issue that's endemic to the field of facial recognition. That's when it's developed. So that's when people say that this is inherently biased, oftentimes they're talking about this very issue, because it's, again, a problem endemic to the field of AI, that the data used to actually train these systems and extract the face prints is not going to be accurate. This is also a problem in other policing contexts too, like predictive policing, where a lot of data in order to predict future crimes comes from unrepresentative data that ends up targeting people of color and communities of color more badly, but that's a conversation for another time. So anyway, moving on. This leads to a problem of false positives. When a candidate, let's say a top candidate in a list has been identified wrongly, when the system thinks it's made a match, but that match is wrong, that's a false positive. That's a term that's going to come up a lot when we look at the portal. In law enforcement terms, a false positive might mean a wrongful arrest. It might mean someone getting arrested or someone getting questioned or someone getting scrutinized because the system thought it was real, but the person's not actually the match. And so that's how literally those problems in the engineering of the system translate to racial bias. This has already been a problem. I'll share these slides. There are links. Here are 3 Black men who have been arrested already. And these are just cases we know about. It's not easy, as we'll talk about, we can discuss again in a little bit. It's not easy to actually learn where facial recognition has been used. But in these examples from Detroit and even here in New Jersey, people were arrested. These are people who had otherwise sometimes rock solid alibis. They were on the other side of the state or somewhere else, or had like 50 people vouching for them. And yet they were picked up because of facial recognition. This is now another important point. So racial bias is really discussed and is something to talk about when talking about the system itself. It's biased. The choice of image databases can be biased if you use mugshots of arrestees and just rely solely on that. But one thing I think we really also want to impress is that even if the algorithm performed equally for all types of people, which is actually, those engineering problems could be overcome, and some systems can perform better than others and people can improve on those, it still wouldn't be enough. And this is where I think a lot of your experiences knowing police, knowing how police use the tools at their disposal come into play. Inevitably, it's going to be communities of color that are most subject to these tools. it's going to be them who are the ones who are constantly being pinged in the database. So if there are going to be errors produced, it's more likely going to happen to people of color than white people. There's others just sort of like sundry issues that just accompany the use of tools, like the fact that the image quality from a surveillance camera at night might not be so great. There might be just general recognition issues, and I know Jessica can really speak to a lot of those actually. But there might be blurry smartphone photos. There might be issues if these images come from body-worn cameras. They impact people in different ways. And so one of the final points I want to leave with is that, facial recognition, once it's in the hands of the state, they can use it for whatever they want. There were some pretty bad stories over the past 2 years of police departments from all across the country using facial recognition to track down protesters. And, sometimes they would say, oh, well, we thought this person committed some crime, so we tracked them down. But guess what? They were protesting. And so this happened in DC, in Lafayette Square, Pittsburgh, Florida, across the river in New York. And so this is sort of the threat that it poses. Imagine, I just read an article just about the scope of surveillance in Camden, for example, of just how many surveillance cameras there are and how every inch of the city is under view. Any of those videos, if you're walking into a store, a house of worship, a doctor's office, those all are potentially open for you to be scrutinized and pinpointed at any moment, depending on how the facial recognition technology is used. So it really represents this major sort of impact on private lives. There's no reason, for example, we've been talking about still video, but the same principles apply to live video. If you have a streaming video, you could have, it takes more computing power. It might take a little more expensive of a computer, but you can track a person going across the screen. You can track a person's movement throughout the city if they're all linked together. And there's also the issue of, well, there's a wide range of facial recognition vendors out there and little transparency about how they do, when the state procures them, what sort of protections have been put into place, and issues like that. So anyway, this was a really quick overview, but the major sort of takeaways I wanted to leave people with is that, these tools can subject people to an ever-present police surveillance. I really like the perpetual lineup framing. It's, really what's happening here is that people are being subjected to a perpetual police lineup. But now to the second point, they can have inherent racial bias. It's like a lineup where you have the worst eyewitness ever, maybe not the worst eyewitness ever. That's another issue to discuss. But you have an eyewitness who's not great at identifying people of color, and the people in the lineup are predominantly always going to be people of color because of the way that these systems are targeted. That goes to the database issue. And finally, the overall impact, it's just, even with some really strict controls on the police, this can introduce a really major infringement on people's liberties and people's ability to really live freely and safely without fear of government retaliation or official retaliation. So that sort of brings me to the end of my talk. For some reason, this was a nice picture of the Statue of Liberty. It's not there anymore. And anyway, please feel free to email me or my colleague Molly. I can drop her email in the chat. But right now, I think with that, we want to talk about the what the Attorney General's actually asked for in light of what we've talked about today. And so I'm going to hand it over to Jessica to talk about that.
Thanks so much, Dylan. My presentation, such as it is, will be much shorter and less informative than Dylan's, but I did want to introduce everybody to the forum that the Attorney General has put out looking for public comment. So we have a basic sense of what the questions that they're asking are and what additional questions we may want to bring to the Attorney General's attention. Go. All right, can everybody see that? Okay, so this is the website, and I will paste the link into the chat so that everybody has it, where the Attorney General is looking for comments. You'll notice that the initial framing is public input on regulating law enforcement's use of facial recognition technology, which presupposes that the appropriate answer is yes, law enforcement should be able to use it. Many of us, as we've been thinking about this and brainstorming, are increasingly thinking that the better answer is just don't. We'll be curious for your thoughts on that as we move forward. But it starts out by listing, here's some basic blanket prohibitions. So they do seem to get that dragnet surveillance and real-time surveillance of protests is not allowed. Again, whether they would follow these guidelines is a different question. But they propose, I think it's 3 basic prohibitions, and then ask if we agree with them and if there's anything we should add or take away. It provides a little bit of information about how facial recognition technology works, and sets out, I think it's 5 procedures that law enforcement officers would be required to follow when using this kind of technology, and then asks if we agree with that and if we think there should be any additional measures that should be in place, and what ones should be taken away. And then it asks a couple of follow-up questions that I think are particularly interesting about what's the opinion on using it just to generate leads? Because law enforcement will say over and over, this is not probable cause to arrest, this is just an investigative lead. And what additional steps should be taken once an investigative lead is generated that would be required before they get to an arrest warrant. Most commonly in the cases that I've seen where this is actually applied, the next step is to put the individual in a photo array and show it to the alleged witness of the crime to see if they can pick out the individual. Many of you are probably very familiar with all of the problems with the way that law enforcement tends to do photo arrays and eyewitness identifications in general. So all of that, of course, comes back into play when we're thinking about these questions. Dylan mentioned briefly a false positive versus a false negative. The portal's next question talks about basically how much do you care about about a facial recognition database inappropriately matching a surveillance photo to a real photo and saying this is the person incorrectly, as opposed to failing to catch a match that maybe should have been in the database in a world with perfect knowledge. And the facial recognition says, no, sorry, we don't have any reference photos for this. So there's questions about which of those is more important, as well as questions about basically what error rates are acceptable. The National Institute for Standards and Technology has evaluated a number of the different facial recognition products that are on the market and tested them in a variety of contexts to see what their error rate is on a training gallery. And they want to know what do we think is a good false positive rate and a good false negative rate, and which of those matter. Oh, these are new questions since last time we were here. They've updated this. There's some additional questions about what would improve our confidence that demographic discrepancies aren't going to be exacerbated by the use of this technology, what else we should be using it for. And then at the bottom, there's a place to just upload a general comment. If, for example, the correct answer in your or your organization's opinion is, we don't want this being used, period, it probably makes more sense to upload a statement rather than saying, well, yes, I think here's how important all of these things are. Or if you want to bring other issues to the Attorney General's attention, this is the place to do that. You do not have to fill out every section of this comment in order to hit submit. It's interested in what different people and different organizations find important. So feel free to fill out the 2 questions that feel relevant or important to you or to others within your organization, and then leave it at that. I know the ACLU and the OPD are both planning on putting forward pretty comprehensive answers addressing every question, but I don't think that's, in fact, I'm confident that's not expected of everyone who runs through the portal. Does anybody have any other questions just about the portal before I toss it back to Dylan?
Should I stop recording, y'all, or do you want to keep recording for now?
I think with that, I think we can stop recording now and then we can just have a discussion